So here we have number 13 from SAT Prep. It says that if x is greater than 3, then we have this complex fraction. A complex fraction is just a fraction that has other fractions inside of one big fraction. So 1 is your numerator, but then in your denominator, you got 2 other fractions actually in the denominator. Now, the benefit of doing this problem is that this is a multiple choice question. So it's saying if x is greater than 3, that means that you get to decide what value of x you want to use. You can pick any number that's greater than 3. You could pick 4, you could pick 5, you could pick 2.8, you could pick, anything. But I would just pick 4 because that's closest to 3 and that's the smallest whole number that I could use. So let's say try 4. So that means that I'm going to plug 4 in wherever I see an x at. Wherever I see an x at, I'm going to plug a 4 in right here. I'm going to plug a 4 in right here. And I'm going to figure out what that gets me. Then what I'm going to do is I'm going to go to my multiple choices and I'm going to plug 4s in where the x's are in there. And then I'm going to figure out, like, is that number that I get equal to the number I got when I plugged 4 in the original complex fraction? That's how I tell what the answer is. So I can do 1 over 4 plus 2 plus 1 over 4 plus 3, which is equal to 1 over 1/6 plus 1/7. And then these two fractions have a different denominator, so we need a least common denominator, or a LCD. The LCD of 6 and 7 is 42. So we got 1 over, I'm going to just bring it over here, and then my LCD is 42. 42 divided by 6 is 7. 7 times 1 is 7. So I got 7 for my numerator right there for that part. And then 42 divided by 7 is 6. And then 6 times 1 is 6. So that gives me 7 plus 6 for my numerator. So then I got 1 in my big numerator. And then I got 13 over 42 for my big denominator. So that really means 1 divided by 13/42. Now, when we divide, we do keep, change, flip. So we keep the first fraction, or the first number, which is 1. We change division into multiplication, and we flip the second fraction, which is 42 over 13. After we flip it, it was 13 over 42, now it's 42 over 13. It was 13 over 42, now it's 42 over 13. So now we got 42 over 13. So when I use 4, this original complex fraction is equivalent to 42 over 13. Now what I want to do is I want to go to the multiple choice answers and find which one of these will also give me 42 over 13 when I plug in 4, right? Because that's the answer that I'm looking for. So I try A, right? I plug in 4s. I do 2 times 4 plus 5. Wherever I see an x, I just look for x's, right? I got an x here and an x here, and an x was right here. I plug in 4s. And I do 4 squared plus 5 times 4 plus 6. So then I got 8 plus 5, which is 13. 4 times 4. 4 squared is 16, not 8. 16, not 8. So I got 16 plus 20. 5 times 4 is 20. 16 plus 20 is 36. 36 plus 6 is 42. So this is 13 over 42, not 42 over 13. But if you notice, this is just the reciprocal of the fraction I'm actually looking for. So then I come down here to letter B, and letter B is just the reciprocal of the expression I started out with. Because look where my 2x plus 5 is. It's in the denominator. Look where my x squared plus 5x plus 6 is. Now it's in the numerator. So that means that this is going to be equal to 42 over 13. Because it's the same variables, it's the same expressions, it's just that they're flipped. And that's what I want. I want this to be flipped. So this is going to give me 42 on top and 13 on the bottom. So that gives me 42 over 13, which means my correct answer is B. My correct answer is B. I don't even have to worry about C and D because it's multiple choice and we use process of elimination.